might stumble and get frustrated, but that's all part of the process. But the rewards are immense. The sense of accomplishment you feel when you solve a problem or create something new is unparalleled. With the power of programming, you can bring your ideas to life, automate tasks, and solve complex problems. You can create something from nothing, and that's a powerful feeling. So are you ready to embark on this exciting journey and learn how to speak the language of computers? It's a journey filled with challenges, but also with incredible rewards. Whether you want to build the next big app, create a website, or simply understand how the technology around you works, learning to code is the first step. Let's get started. Every language has rules, and programming languages are no different. These rules are called syntax. It's like grammar for computers. If you don't follow the syntax, your code won't run. Think of it like baking a cake. If you don't follow the recipe, you won't end up with a delicious treat. Now let's talk about data types. Just like we use different types of ingredients in a recipe, programming languages use different data types to store information. Common data types include numbers, text, and true/false values. Finally, we have variables. Think of variables as containers that hold information. We give these containers names so we can easily access the information later. For example, we could have a variable called age to store a person's age. Syntax is crucial because it ensures that the code is readable and understandable not just by the computer but also by other programmers. When everyone follows the same rules, it makes collaboration easier and more efficient. Comments in the code can also help explain the logic, making it easier to understand. Data types are essential because they define the kind of data that can be stored and manipulated within a program. Using the correct data type can prevent errors and make your code more efficient. Variables are the building blocks of any program. They allow us to store, retrieve, and manipulate data. By giving meaningful names to variables, we make our code more readable and maintainable. In summary, understanding syntax, data types, and variables is fundamental to becoming a proficient programmer. Master these concepts, and along the way to writing a clean, efficient. Operators are
Welcome back
symbols
to
that
Lula
perform
Talk.
specific
Today
operations
we're diving
on
into
data.
the fascinating
They're
world
like the
of
tools
programming
in our
languages,
programming
the languages that
we use
computers
them to
understand.
add, subtract,
Every app,
multiply, and
website,
divide
and game
numbers.
starts with
We can
lines
also
of
use
code
them to
written in
compare
these
values
languages.
and see if they're
We'll explore the
equal,
origins
greater
of some of the
than,
most
or
popular
less than.
languages
For
today and how
example,
they shape the tech landscape we know and love.
values together. The minus sign subtracts one value from another.
Our journey
The
begins
asterisk
back in the early
multiplies two
1970s
values,
at the
and
legendary
the
Bell
forward slash
Labs.
divides
This is where
one value by another. Operators are essential for performing calculations and making decisions in our code. They allow us to manipulate data and create dynamic programs that can respond to different inputs and conditions. Imagine you're writing a program that needs to make decisions based on certain conditions. This is where if-else statements come in. They allow our code to branch out in different directions depending on whether a condition is true or false. Think of it like choosing a path at a fork in the road. If a certain condition is met, we take one path. If not, we take the other. Loops, on the other hand, are like taking a detour that brings us back to the same point. They allow us to repeat a block of code multiple times, which is incredibly useful for tasks like processing lists of data or performing repetitive actions. Section 5. Python, the friendly giant. Python is often considered the friendliest programming language for beginners. It's known for its simple syntax, which resembles plain English. This makes it easier to learn and read. Python is also incredibly versatile. You can use it for web development, data science, machine learning, and more. Companies like Google, Facebook, and Instagram all use Python extensively. One of the key advantages of Python is its vast ecosystem of libraries and frameworks. These are pre-built modules of code that you can use to add functionality to your programs without having to write everything from scratch. Section 6. Java, the workhorse of the web. Java is another popular programming language known for its write once, run anywhere capability. This means that you can write Java code on one platform like Windows and run it on another platform like macOS or Linux without any modifications. Java is widely used for building enterprise-level applications, Android apps, and web servers. It's a powerful and robust language that has been around for decades. While Java's syntax is a bit more complex than Python's, it enforces strong coding practices that can help you write more maintainable and scalable code. Section 7. C++, the powerhouse of performance. C++ is a high-performance programming language that gives developers a lot of control over system hardware and memory management. It's often used for developing operating systems, game engines, and other performance-critical applications. Learning C++ can be more challenging than learning Python or Java, but it provides a deep understanding of how computers work at a low level. If you're interested in game development or systems programming, C++ is an excellent language to learn. Section 8. Tips for aspiring programmers. Learning to code can seem daunting at first, but it's an incredibly rewarding journey. Start with the basics and gradually work your way up to more complex concepts. Don't be afraid to make mistakes. It's all part of the learning process. Practice regularly and seek out resources like online tutorials, coding boot camps, and books. Most importantly, have fun and enjoy the journey. Remember that programming is a creative field. There are multiple ways to solve a problem, and the best way is often the one that makes the most sense to you. Section 9. The rewards and challenges of coding. Learning to code is like unlocking a superpower. It's a skill that opens up a world of possibilities, allowing you to bring your ideas to life in the digital realm. Whether you're building a simple website or developing a complex software application, coding gives you the tools to create something from nothing. It empowers you to create, innovate, and solve problems in ways you never thought possible. The ability to write code means you can automate tasks, analyze data, and even build games or apps that can be used by millions. New perspective on technology and develop valuable problem-solving skills that extend far beyond the realm of computer science. These skills are highly transferable and can be applied to many different fields, from engineering to finance to healthcare. However, coding can also be challenging. It's not always smooth sailing. There are times when you'll feel stuck, unable to figure out why your code isn't working as expected. It requires patience, persistence, and a willingness to embrace the unknown. You'll need to be comfortable with trial and error and be prepared to spend hours debugging and troubleshooting. You'll encounter bugs, errors, and moments of frustration. These obstacles can be disheartening, but they are also opportunities to learn and grow as a programmer. But the feeling of accomplishment when you finally debug a tricky piece of code or build a working application is unparalleled. It's a moment of triumph that makes all the hard work worthwhile. So embrace the challenges, celebrate your successes, and never stop learning. The journey of coding is a continuous one, filled with both highs and lows, but it's a journey that is incredibly rewarding. The world of programming is vast and ever-evolving, and there's always something new to discover. Whether you're a beginner or an experienced developer, there's always more to learn and new technologies to explore. So keep coding, keep experimenting, and keep pushing the boundaries of what's possible. Have you ever wondered how computers understand our commands? It's fascinating to think about, isn't it? We interact with these machines every day, but how do they know what we want them to do? They don't speak English, Spanish, or Mandarin. Instead, they have their own unique languages designed specifically for them. These are called programming languages.
Python was conceived in the late 1980s by Guido van Rossum, a Dutch programmer. Inspired by the ABC language, he started working on Python during the Christmas holidays of 1989. Named after Monty Python, the language was officially released in 1991. Python's popularity has soared, becoming one of the most widely used programming languages today. Its simplicity and readability attract both beginners and professionals. Python supports multiple programming paradigms, adding to its versatility. Its rich standard library supports many common tasks right out of the box. The open-source nature of Python has fostered a large and active community. The Python Software Foundation ensures its ongoing development and relevance in the tech industry. Python is a high-level Web development is one of the most common applications of Python. Frameworks like Django and Flask make it easy to build secure and scalable web applications. Django is known for its dry principle and built-in features for authentication, database connections, and URL routing. Flask is lightweight and offers flexibility, making it ideal for smaller projects. Python's simplicity and powerful frameworks reduce complexity, developed the C programming focus on user experience. C quickly gained a reputation for being powerful, efficient, and incredibly versatile. Data science is a field where Python truly shines, writing its powerful libraries such as NumPy, Pandas, and Matplotlib provides tools for data manipulation, analysis, and visualization. NumPy is known for its efficient handling of arrays and matrices, which are fundamental in scientific computing. It provides a range of mathematical functions to perform operations on these C is awesome, but what if we could do even indispensable for numerical C++? Pandas builds on NumPy with object-oriented programming, allowing developers to write more complex and organized
Imagine a programming language.
This was crucial as software became more sophisticated, enabling graphical user interfaces and complex games. Even today, C++ is known for its performance and control, powering web browsers, operating systems, and game engines.
These instructions are precise and must be followed.
In the mid-90s, the internet was exploding, and Sun Microsystems wanted a language that could run on any device. That's where Java came in with the idea of write once, run anywhere. Java was designed to be platform independent, making it popular for enterprise applications, web development, and mobile apps. Remember those annoying Java applets that used to crash your browser? They helped pave the way for today's rich web experiences. Java's portability made it a game changer.
But the rewards are immense. The sense of
Chapter 4, JavaScript, bringing
a problem or create something new is unparalleled. With the power of programming, you can bring your ideas to life, automate tasks, and solve complex problems. You can create something from nothing, and that's a powerful feeling. So are you ready to embark on this exciting journey?
The web to life. In 1995, Netscape programmer Brendan Eich was tasked with making the web more dynamic and interactive. JavaScript was created to add interactivity to web pages like animations and form validation. In just 10 days, Eich created the first version. Welcome back to Lula Talk. Today we're diving into the fascinating world of programming languages, the languages that computers understand. Every app, website, and game starts with lines of code written in these languages. We'll explore the origins of some of the most popular languages today and how they've shaped the tech landscape we know and love. Our journey begins back in the early 1970s at the legendary Bell Labs. This is where Dennis Ritchie developed the C programming language. C quickly gained a reputation for being powerful, efficient, and incredibly versatile. It was designed for system programming, writing core software like operating systems and compilers. C influenced a whole generation of programming languages. It's like the grandparent of the programming language world, still relevant and respected. Fast forward to the 1980s and Bjarne Stroustrup thought, C is awesome, but what if we could do even more? Enter C++. Stroustrup supercharged C with object-oriented programming, allowing developers to write more complex and organized code. This was crucial as software became more sophisticated, enabling graphical user interfaces and complex games. Even today, C++ is known for its performance and control, powering web browsers, operating systems, and game engines. In the mid-90s, the internet was exploding, and Sun Microsystems wanted a language that could run on any device. That's where Java came in with the idea of write. A data scientist can easily load datasets, process them, and extract valuable insights using Pandas' intuitive API. Matplotlib is a plotting library that enables the creation of static, interactive, and animated visualizations in Python. It provides an object-oriented API for embedding plots into applications, making it an essential tool for data visualization. Whether you need to generate simple line graphs or complex 3D plots, Matplotlib provides the capabilities to display data effectively. Python's versatility and ease of use make it a favorite in the data science community. The language's ability to handle large datasets combined with its extensive library support makes it an essential tool for data scientists working in various sectors from finance to Python was conceived in the late 1980s by Guido van Rossum, a Dutch programmer. Inspired by the ABC language, he started working on Python during the Christmas holidays of 1989. Named after Monty Python, the language was officially released in 1991. Python's popularity has soared, becoming one of the most widely used programming languages today. Its simplicity and readability attract both beginners and professionals. Python supports multiple programming paradigms, adding to its versatility. Its rich standard library supports many common tasks right out of the box. The open-source nature of Python has fostered a large and active community. The Python Software Foundation ensures its ongoing development and relevance in the tech industry. Python is a high-level programming language, abstracting complex hardware details. This makes Python code easy to read and write. It is an interpreted language executed directly without compilation. Python features dynamic typing, adding flexibility. Its cross-platform compatibility is a significant advantage. The Python community is robust and supportive, offering extensive resources. Web development is one of the most common applications of Python. Frameworks like Django and Flask make it easy to build secure and scalable web applications. Django is known for its dry principle and built-in features for authentication, database connections, and URL routing. Flask is lightweight and offers flexibility, making it ideal for smaller projects. Python's simplicity and powerful frameworks reduce complexity, allowing focus on user experience. Data science is a field where Python truly shines. Its powerful libraries such as NumPy, Pandas, and Matplotlib provide tools for data manipulation, analysis, and visualization. NumPy is known for its efficient handling of arrays and matrices, which are fundamental in scientific computing. It provides a range of mathematical functions to perform operations on these data structures, making it indispensable for numerical computations. Pandas builds on NumPy by offering data structures and operations for manipulating numerical tables and time series. It is perfect for tasks like cleaning data, transforming it, and performing complex data analysis. A data scientist can easily load datasets, process them, and extract valuable insights using Pandas' intuitive API. Matplotlib is a plotting library that enables the creation of static, interactive, and animated visualizations in Python. It provides an object-oriented API for embedding plots into applications, making it an essential tool for data visualization. Whether you need to generate simple line graphs or complex 3D plots, Matplotlib provides the capabilities to display data effectively. Python's versatility and ease of use make it a favorite in the data science community. The language's ability to handle large datasets combined with its extensive library support makes it an essential tool for data scientists working in various sectors from finance to academia. Section 5, Python for Automation and Scripting. Automation is another area where Python excels. Its ease of learning and powerful libraries make it a popular choice for writing scripts to automate repetitive tasks. Python's OS and sys modules provide functions to interact with the operating system, allowing developers to automate file and directory manipulation, as well as system processes. The Python package PyAutoGUI enables developers to programmatically control the mouse and keyboard. This is particularly useful for automating tasks in a graphical user interface environment. Whether it's filling out forms, downloading reports, or scraping data from web pages, Python scripts can save significant time and reduce the potential for human error. For network automation, Python's Paramiko and NetMiko libraries allow developers to automate tasks involving SSH and other network protocols. This capability is particularly useful in managing network configurations and monitoring network devices. Python's extensive standard library, combined with its ability to integrate with other technologies, makes it a powerful tool for automation. By automating mundane tasks, developers can focus on more strategic projects, boosting productivity and efficiency. Section 6. Game development with Python. Python is not just for data science and web development, it also has applications in game development. Pygame is a cross-platform set of Python modules designed for writing video games. It includes computer graphics and sound libraries, allowing developers to create fully featured games with Python. Pygame provides support for creating two-dimensional games, which is a great starting point for beginners interested in game development. It offers functionalities for rendering graphics, input, and managing game states, which simplifies the game development process. Focus more on game mechanics and design rather than dealing with low-level programming details. In addition to Pygame,